Dear friends, in the series of learning aerodynamics, let us discuss one important and interesting phenomenon in the aircraft climbing. So, when the aircraft is climbing or in the climbing, okay, under the climbing condition, then we'll just see one interesting phenomenon, and that is nothing but when the angle of climb increases, the rate of climb decreases. So that is okay. This is happening for different altitude. So for the different altitude, okay. So when the angle of climb increases, then rate of climb decreases. So that is, you can just see here. When the angle of climb is theta 1, then rate of climb we are finding it, okay, that is RC1. When the rate of angle of climb is theta 2, then rate of climb is RC2. So obviously we just this theta 1 is less than theta 2, then rate of climb RC1 is greater than RC2. So that is okay. We are observing it from the this graphical representation. So this, from this even from the quantity wise also, we can just say that this rate of climb is higher than this one. So how this happens? So this is what the question, and this is what the topics and on which we are discussing, especially what happened when the hodograph, not in the hodograph, in the rate of climb versus height. So horizontal axis is the rate of climb and the vertical axis is the height, in which from where we are finding the observed ceiling and service ceiling. So that we all know that service ceiling occurs when the rate of climb equal to 100 feet per minute for the piston engine and 500 feet per minute for the jet engine. So this all we all know. And now what happened from this graph, what we are understanding, as the height increases. So from here what we just say, as the height increases, then what is happening with the rate of climb. So that is okay, we have to understand. And the horizontal axis also we can see that so 0 to this kind, okay, rate of climb, okay, in this direction rate of climb increases. So whatever, okay, the curve, this curve touches the horizontal axis, so that point would be the maximum rate of climb. So that is what okay, here just we are mentioning it. So this is nothing but maximum rate of climb. So this is the point. So this point is the maximum rate of climb. Now that is occurring, maximum rate of climb is occurring at 0. When the height is 0, that time we are finding it. So that maximum rate of climb. Now what we have to understand, as the height increases, what happened? The thrust produced by the engine decreases. So because of that reason, what happened? The power required, or okay, the excess power, because excess power now is nothing but it is the difference between the power available minus power required. So that excess power decreases because of the decrease in the thrust. The available, okay, the excess power is decreases. So maximum rate of climb occurs for the maximum excess power. So based on the, because we all know that from this curve, this is the power curve. So this is the power required and power available. So from this we know, okay, so how it is, okay, just so maximum rate of climb occurs based on the maximum excess power. So that is happening because of the at particular altitude or at particular condition, just we are getting the maximum excess power. So in that condition we also can say that drag will be lesser. That means power, that means thrust required to overcome the drag, so that will be very small. So because of that reason we are having the maximum excess power. So as the height increases, we are just seeing that from this curve, we are just seeing it is okay, the rate of climb is decreasing. So that is what, okay, at any given altitude, whatever we see at any given altitude, as the height increases, our rate of climb decreases. So that is okay, one thing we can understand from this graph. So and it can go only up to the flight, okay, the flight can climb only up to service ceiling, because beyond the service ceiling, if it goes to moves towards that, it will be it may reach the dangerous condition or unsteady conditions. So that may not be advisable, that means to fly beyond the service ceiling. So as from the maximum rate of climb, it is okay, it can go only up to service ceiling. That is what just even in this graph, okay, which we have drawn it for the particular altitude, that is also says, so maximum rate of climb we are achieving at a particular angle. So then beyond that okay, beyond the maximum rate of climb also, so we can just go for that means the angle of climb, okay, can be we can go up to the maximum angle of climb. So in that condition, our rate of climb is smaller. So that is also we can understand from this graph. So from this condition, from this graph, as well as from this graph also, after reaching the maximum rate of climb, then this statement, whatever we said, as the angle of climb increases, rate of climb decreases, this statement, okay, proved. Then because as we have seen that from this curve, it can go only up to the service ceiling. After the maximum rate of climb, it can go only up to the service ceiling. So that is a condition. After having the, because this is what the maximum rate of climb for the maximum excess power. Beyond that, after that, it will be the power, okay, power available minus power required, that excess power, power quantity, that will be decreasing. So because of that reason, as we are okay moving higher and higher, then we are also having a lesser excess power, and because of that rate of climb also decreases. This, so I think this is very clear. Why do we have a lesser rate of climb as we are okay going steeper and steeper? Because as we are flying higher and higher, or moving to the higher altitudes, then we are also having that means maximum, that means we are also having a higher climb angle. So as we, if you are having the, if you are flying with a higher climb angle, obviously our rate of climb will be decreased at a different altitude. That is what we have to understand. So whatever the statement we said, so that is proven, or that is proved from this both the graph, this from this graph as well as from this graph. I hope okay this is clear. How, why do we have that means lesser rate of climb for the higher, for the higher climb angle.